This is Algebra 1B, Part 1, Unit 3, and we are doing the Unit 3 sample work. Sample work is vocabulary, so as you go through your unit, you will see keywords, usually on the second slide of the lesson. Write down the keywords, write the definitions of the keywords, and then give specific examples of those definitions. So Unit 3, Lesson 1, Adding and Subtracting Polynomials, has some keywords. Let's go ahead and look at them here. I'm just going to do them in the order they are in. Binomial. Bi meaning two. Nomial, name, or nomos, name. Binomial, two names. Basically, it is a polynomial. A polynomial. Polynomial with two terms. For x plus 5 is a binomial. Okay. Degree of a polynomial. The highest exponent in a polynomial. Now there's actually more to it than that, because you can have monomials that have more than one variable, in which case you add up the exponents. But in general, the ones we deal with, you're going to be dealing with the highest exponent. So 4x to the third minus 5x squared plus 7x plus 2 has degree 3, because 3 is the highest exponent of a term. Degree of a polynomial. Degree of a monomial. Okay. The power, or exponent, the exponent, or sum of exponents of a monomial. Couple of examples. 5x to the third has degree 3. 6x squared y to the fourth has degree 6, because it's 4 plus 2. Okay. Degree of a monomial. And I actually got those out of order. Oh well. Like terms. Like type terms. Like terms. Terms with the same variables and exponents. Okay. The following are like terms. 6x plus 8x are like terms because they have the same variable and exponent. You can combine like terms. 6x and 8x makes 14x's. 9x cubed y's plus 3x cubed y's. It has all the same variables and the same exponents. So 9x cubed y's and 3x cubed y's is 12x cubed y's. Okay, those are like terms. Monomial. A polynomial with one term, 3x, or 5x squared y. Those are both monomials. 2 is a monomial. standard form of a polynomial? Okay. Terms in descending order. Of exponents. So 6x cubed minus 4x squared plus 3x minus 6 is in standard form because it's in 3, 2, 1, and 0 order of exponents on the variable. Standard form of polynomial. Trinomial. That's a polynomial with 3 terms. Example, 4x squared minus 5x plus 6. 3 terms. Okay, that's all the keywords for Unit 3 Lesson 1. Unit 3 Lesson 2, multiplying by binomials. Let's see what they have here. Greatest common factor, monomial and polynomial. We've already defined monomial and polynomial, but we haven't defined greatest common factor. Greatest common factor, also called the GCF. The biggest number that divides all terms evenly. Okay, so in this example, 8x squared plus 12x, the GCF is 4, because 4 is the biggest number that divides both 8 and 12. 4 times 2 and 4 times 3. And x, because both terms have an x and the smallest exponent is 1. 4x, greatest common factor. Okay, and we learn to factor out the greatest common factor. Okay, multiplying binomials. Okay, that's lesson 3 here. Let's see what keywords here. Binomial and trinomial, already defined. Multiplying special cases, lesson 4. Binomial, square of a binomial. Square of a binomial, let's write that one down. Square of a binomial. A binomial multiplied by itself. And we use the formula a plus b squared equals a squared plus 2ab plus b squared. Example, x minus 4 squared equals x squared minus 2 times x times 4, which is 8x, plus negative 4 squared, or 16. Square of a binomial. Okay, that's lesson 4. Lesson 5 is mid-unit review. Lesson 6, factoring. Binomial, factor, and trinomial. We do not have factor yet, so factor. Factor. factor, if I can spell, factor, write as a product, that means multiply, of two or more factors. Example, x squared plus 6x plus 8 factors to x plus 2, x plus 4. Factor. To factor is a verb and factors is a noun. Okay, and then trinomial and binomial we've already defined. Lesson 7. Let's see if there's any keywords here. Binomial, factor, and trinomial. We've already defined those. Lesson 8, special cases. Difference of squares and perfect square trinomial. Let's make some room here. Okay, difference of squares. Subtracting two perfect squares. Pattern is a squared minus b squared equals a plus b times a minus b. Specific example, x squared minus 25 equals x plus 5 times x minus 5. Difference of squares. Perfect square, trinomial. A trinomial that factors as a perfect square. Example, x squared plus 10x plus something here, and here's the way I think it through. 10 is 5 plus 5. So what is 5 times 5? And that's what I add. 5 times 5 is 25, and that is a perfect square that factors as x plus 5 squared. Perfect square trinomial. Okay, that's lesson 8. And then there's a review, so that's it.